Let's see if it works. And okay. Oh, my pen works. Thank God. All right. So I've been having problems with my pen. It's no excuse. I know it's Sunday, and this video should have been up a little bit earlier. So let's get to this. Sorry, guys. I'm just giving myself some room. All right. Let's go with the first problem. Besides, also, guys, this was Masters weekend, so I was watching the Masters too. You can move the like terms next to each other if you like. Don't bother me if you don't. Okay, but this way I know that I'm combining these two. Okay, it helps. So negative 12a and minus a, it's negative 13a. Don't forget there's a little hidden one here. I want to write it down, and then minus 6. We'll do it in order. That combines with no one. And then the v's, I have a 14v here and a minus v. 14v minus 1v is positive 13v. And then I can combine these two because they're like terms. Negative 21p minus 8p is negative 31p. Nope, sorry. Where did I get 31 from? Negative 29p. My apologies. Here I have a k squared and a k squared, so these two are like terms, so that gives me 2k squared. Right? Remember, we're adding. Okay. Do we have a k here by itself? Yeah, that combines with num 1. And these two m's combine with each other, and again, negative 8, negative 21 is negative 29m. Okay. Last one, not last one, but next one. A squared b cubed. Well, there's an a squared b cubed here, and there's another a squared b cubed. So I can combine those two. That's 4 minus 6, or negative 2a b cubed. And then I'm going to put this guy. Actually, this guy should have come first. So I'm going to put him in the front. Negative 12b to the 5th power. And then negative minus 9a goes to the end. Just put him in, right? It's easier to grade too. It's easier to look at, and everybody writes in the same standard notation. Moving on, just a distributive property, so no big deal here. That's negative 28k minus 32. This one is, again, if you want to put a little one there, you can. By now, I am not going to, I hope that you don't, because it's just really not necessary. So we know it's a minus sign in front of the parentheses, which means everybody inside comes out the opposite. And there's an extra plus sign that shouldn't be there, right? Because a negative times a negative is positive n. Negative times a negative again will give you positive 9a. Bottom here, there's multiply, so let's multiply the coefficient. 4 and 5 is 20. And that would be x to the 4th power. We add the exponents, and then we get y6. Positive, negative, and negative. 4 times 12 is 48. X, y5. Here, notice that, again, if you want to imagine a 1, it's a positive 1. So if we remove the parentheses, right? The idea is that you're multiplying that invisible or imaginary 1 that's there. And then everybody just comes out the same way. Okay, but that's the idea. We're not just throwing the parentheses away. Okay. Where am I? Okay, so next. Okay. So here, did I just do this? Yes, I did the first 4. Okay. And then let me do the bottom. So now it's a fraction. So negative times a positive is a negative. And what's 3/5 of 15? I like to divide this 15 into 5, right? Divide that and then multiply by 3. So that could be something that you might want to do. Or just figure out what 3/5 of 15 is. So 5 divided by 5, 15 divided by 5, I'm sorry, is 3, and 3 times 3 is 9. And then m4, right? W, because this m. Negative and negative is a positive, and 3/5 of 20 is 12. M to the 5th, PW, put them in alphabetical order. The last one, negative, negative again is positive, and 3/5 of 5 is just 3. And 3m4w2. That would have been a final answer. 5th, 7th, positive and negative is a negative, and then 14 divided by 7 is 2, and 2 times 5 is 10, so negative 10m. Again, positive and negative is a negative. What do you call? 35 divided by 5 is 5, and then times 5 would be 25 in B. positive and negative. We just did this. Let's do the last one is a negative, and then 7 divided by 7 is 7, and sorry, it's 1, and 1 times 5 is 5g. Okay. This video might be shorter than I thought it would be, which is a good thing. Okay, so it says here combine, do the distributive property and combine like terms. So I might need a little bit more space. Okay, that should be okay. All right, so first one, I cannot combine the like terms, right? Because I need to do this. So 3k and 2k is 6k squared, minus 3k and 4m is 12km, plus 12 minus 8 squared. Let's combine the like terms. So I can combine this fellow with this fellow. I can get negative 2k squared. And then the rest don't combine with anybody, right? Because they're all different. Fine, faster. Again, let's do distributive property first. We get 40. 8 to the 7 minus 5 times 12 is 60. 8 to the 6 minus 6a7 minus 7a. Is there any like terms? Yeah, we have this guy here and this guy here can be combined. 40 minus 6 is 34. 8 to the 7th power minus 60a to the 6th power and minus 7a, right? The other two are completely different species. Distributive property first, 2p4 minus 2wp cubed. I'm putting them in alphabetical order when I do the variables. Minus 5, right? And then I'm going to multiply negative 3p squared, and p is going to give you negative 3p cubed. And the last two is going to be negative and negative is a positive, and I get 3w3p2. Okay, so are there any like terms? Let me put this in. So this is, I'll put this in the front, plus 3w, right? Actually, I'm sorry, the highest, what do you call? Let me go back. I just want to put it in ascending, descending order. So the variable is the highest exponent I'll put first. So 2p4, that combines with no 1. And then we have these two here. That will be in second place. And again, that combines with no 1. There's, well, right? Because there's no other w3p2. And then I'm going to put this guy. No. And then I'm going to put this guy here. It's a good question. I don't know which of these two comes first. So I would put this, and then this. Now, if you didn't put it in what you call order of ascending order, a descending order, I'm sorry, right? The highest exponent first, and then the second highest, and so forth and so forth. You won't lose any points, but I'm asking you. It just makes my life easier when I have to grade it and I don't have to see 12 different versions. Okay. Next one, 12 does nothing, minus 6h does nothing, but the 4 here is going to be multiplied, so we get negative 4h plus 28, right? Distributed properly. And then plus 9h. Combine like terms, yeah, we have a bunch. This, change colors for a second. Let's combine this fella, minus 6h, minus 4h, and plus 9h. So that was going to give me negative h, right? Because negative 6 and negative 4 is negative 10, and negative 10 plus 9 is negative h, or negative 1h. And then the 12 and 28, they're both positive. Combined, so you give 40. 19k plus 14x plus 56k minus 9 minus k minus 15. Okay, so I didn't remember this. And remember there's a 1 here. At some point, I'm going to stop saying that there's a 1 because you should get it by now. So now let's do the case first. So I have a 19k here. I have a positive 56k, and I have a minus k. Let's combine these three. 19k and 56k is, I don't know, 75, and 75 minus 1 is 74. So 74k, and then plus 14x. And then these two combined, minus 24. Okay, negative and negative is a positive, and 1/6, so I'm just going to get 1/6m. Right? Again, a 1/6 of 42 is just 7, positive 7. And then negative and negative again is positive, and 1/6 of 18 is 3. Don't forget the k. And then minus 23 minus 17m. Is there anything we can combine? Yes, there is. So we can, well, 3k combined with no one, right? So that, put that here. So 3k, I can combine this guy with this guy. So it's 1/6 minus 17. So it's going to be minus 15 and 5/6m. Right? So if I do negative 17 plus 1/6, right? What do I get? I get 16, sorry, 16 over here. 16 and 5/6, negative 16 and 5/6m. And then the 7 and the 23, positive 7 and minus 23 equals negative 16. Okay. Okay, so push this down here. And let's go into these. So again, negative, that does nothing. Now this does, there's a distributive property here and distributive property here. Negative and the positive is a negative, and 1/3 of 45 is 15. M times m is m squared. Negative 1/3 and negative 12 is positive, and 1/3 of 12 is 4. Don't forget 4km. Okay. And then negative times a negative is a positive, and then 3 divided by 5 is 6. 6 times 2 is 12. We get 12m. Negative times a positive is a negative, and 2/5 of 15. 15 divided by 5 is 3 times 2 is 6. Don't forget 6km. Like terms. Well, this is highest exponent, so I'm going to put that in first. And then I'm going to do in order, so we're going to get the km. So let's do the km, because alphabetically that comes first. So these two get combined. So 4km and minus 6km is negative 2km. And then negative 4m, the square, sorry, and positive 12m is positive 8m. Here, there's a negative, so everything comes out opposite. There's a positive in front of that parenthesis, so everybody comes out as they are. Combine like terms, so let's do the k's first, because they alphabetically first. 9k and 7k is 16k. And then negative 4m and negative 1m is negative 5m. Okay. I will come back to these guys. I know we did it in class, but I'm going to redo it again. Okay, so some, I know there was a couple there that I wrote wrong, or we just, so let me just finish the rest. Okay, and I'll come back to the sequences. Okay, so let's do these first. So let's take out, we want to take out the greatest common factor, right? So greatest common factor between 21, 36, and 18, let's see, is 3, because 3 goes 21, and 36 and 18. Is there any other number? 7? No, 6. So 3 is the highest. Right, so 3 is in common in all those. We want to check the variables. There are a's in each of them, so we can pull out an a. So we're going to pull out the a with the smallest exponent, so that's going to be a squared. B isn't common in all of them. Good, so we can pull out a b, and the b with the smallest exponent is that one. So now, all you got to do is figure out what this multiplied, right? By what, to give you these 3 terms inside. So 3 times what's 21 is going to be 7 times a, just 7, okay, because a squared, b squared are already there. So again, you can check 3 times 7 is 21, and then a squared b would be next to the 7. So that's good. So next one, 3 times what's 36 is 12. We need an a cube. We already have a squared, so I'm going to add an a. We need a b4, and we have a b here, so I'm going to add a b to the 3rd power. 18, 3 divided by 18 divided by 3, 6, and we need an a fourth. But we have an a second, so we need another 8 to the 2nd power. So that's going to give us the a4. B cubed, we have a b, so we need to multiply by b squared. So that's our final answer. Greatest common factor here is a 4. X is not present in all. Is the y present? Yeah, the y is present in all those terms, and the y with the smallest exponent is the y to the 1st power. So again, let's see what we get. So 12 divided by 4 is 3. X cubed, right? Because we need an x cubed. We need a y squared, so we're only going to put a y, z. And again, double check. Does this give you that? 4 times 3 is 12. X cubed, y times y is the y squared, z. Good. 20 divided by 5, 20 divided by 4 is 5. We need a y cubed, so we have a y here, so we need to make it a y squared, and we need a z, so we're going to add a z. Multiply those two and see if you get the middle term. Finally, 4 divided by 4 is just 1, and this particular term has an x squared. We're going to add an x squared. So it's 4y times x squared, give you that last term. 4 times this invisible 1 is 4, x squared y. Perfect. 7 is you can pull out a negative 7 if you like. It's up to you. Is there anything in common? Absolutely not. So 35 divided by 7 is 5, negative 5. And we need the variable m, right? Minus 2k minus a. So again, do distributive property and make sure that when you multiply, you get this particular expression. 9, 12, 6, and 30. 3 would be the greatest common factor. Do they share m's? Yeah, and they share m's, and that's the only variable that they share. So 1, 2, so 4 terms here, right? So how do we get these? So 9 a.m. So 9 divided by 3 is 3. M we already have, so we need an a here. So it's 3m times 3a give you 9 a.m. Yes, it does. 12 divided by 3 is 4. We already have an m, but we need to add a p, so 4p. 6mx, so 6 divided by 3 is 2. The m is already present, we need an x. And the last one, 30 divided by 3 is 10. It already has an m here, so we don't need another m, and that's would be my final answer. Multiplying polynomials, we did a little bit of this, not too much, but again, I told you it was just simply, if you think of it as the distributive property twice, that's literally all you're doing. You're multiplying, you're doing the distributive property twice. If you can think of that, remember that, you'll be fine. So, and if there's anything to combine after, you can. So the first thing we're going to do is going to do this guy. So 2x times x is 2x squared. 2x times 6 is 12x. Negative 5 times x is negative 5x. And then negative 5 times positive 6 is negative 30. Combine like terms? Yes, we can. These two guys can be combined. And that's going to give me positive 7x minus 30. Right? Those are the only two terms that can be combined. Okay? After those, 4a and 2k is 8k. 4a and negative 8 is going to be 32a. This 2, negative 5a and 2k is negative 10k. And negative 5 times negative 8 is positive 40. Is there anything I can combine? No, all the terms are different variables, right? Bottom one, so it's x cubed times 2x. We get 2x to the 4th power. X cubed and y squared, we get minus x cubed y squared. And then negative 3y and 2x is going to give me negative 6xy. And then negative 3y and negative y squared is going to be positive 3y cubed. Combined, are there any like terms? No, there aren't. Next two, 2m and negative 3m is negative 6m. 2m and negative w is negative 2mw. These ones are positive, right? Negative and negative is positive, and we're going to get 4 times 3 is plus 12mw cubed. And then the last one is negative times a negative, which is a positive, and we get 4w 4th power. So let's just write this pretty. So 4w4 plus 12mw cubed, and alphabetically this will come first, and this will come last, just to write it in order. Okay? Oh, and now we get to do the sequences. I know we've did it in class, but just in case you need something to look at, let's talk about it. So let's do these two first. I do first difference, and this is 3, and you notice it's 3, and you notice it's 3, and you notice it's 3. So that tells us it's a linear sequence, right? So, and it's a sequence that goes by 3. So a 3x sequence goes 3, 6, 9, 12, 15, etc., right? So notice that we need our sequence to be 6, 9, 12, 15, 18. So I need my first term to be a 6, not a 3. So how do I adjust? So far we know that our answer is this, but it's not a 3x sequence, right? It's a 3x sequence that needs a little bit of an adjustment, and you can clearly tell that instead that we have to adjust it by adding 6. And another way you can do that is subtract that first one. Sorry, by adding 6, by adding 3. Another way you can find out how to get this number is by subtracting the original one, right? Minus the sequence. So 6 minus 3 is 3, 9 minus 6 is 3, 12 minus 9 is 3, 15 minus 12 is 3, and so forth. So again, this goes here. Okay? So just to confirm, let's say I wanted, I don't know, the 45th term in this sequence. What would be this particular number? We can use yx. We can use that little function that we just found, right? And the 45, we replace it here. So we get 3 times 45 plus 3. 3 times 45 is, I have no idea, 115 goes 135 plus 3. And the total would be 138. So 45th term, if you were to continue the sequence 6, 9, 12, 15, 18, 21, 24, blah, 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 blah. And the 45th term of this sequence would be 138. So much easier to find this, right? To help us find any term in that sequence. Okay? So these are the easy ones. Let's do another one here. First difference. Notice it's a 5, 5, 5, a 5. So nothing big here. So we know it's going to be 5x, right? And a 5x sequence, right? How does it go? It goes by 5. So it's 5, 10, 15, 20, 25, etc., etc. And those, right? So I know that part of my sequence is 5x, but I have to make an adjustment to this sequence because I don't really want a 5, I want a 1. I don't really want a 10, I want a 6, right? So how do I adjust this 5x sequence so that I actually get 1, 6, and 11? Obviously, if you subtract, you know, it's minus 4, minus 4, minus 4. So there is our little function here, okay? So again, if I wanted to find, let's say, the 345th number in the sequence, right? You're not going to write 1, 6, 11, 6, 21, 26, 31, etc. You're not going to do that 340 times. Rather, you much rather use this. So it would be 5 times 345 minus 4, and I have no idea why I picked such a big number. It's just to show you that 25, 22 goes to 17, so it's 1725 minus 4 would be 1721. So the 345th term in this sequence would be 1721. Okay, or if you have lots of time, you could just go 26, 31, 36, 41, etc., and go all the way to 3 and do that 345 times. Okay, so let me go and forget which one we didn't do or which one was the wrong one, but doesn't matter. All right, so moving on, let's do these. So we want to find the function here. So this looks like 17 minus 6 is 11. 34 minus 17 is 17. 7 minus 4 is 3. 5 minus 3 is 2, 23, so it's going by 6. Okay, so 23, and this should be 29. Right, so that's the first difference. Notice that they're all different. So if they're all different, we have to find a second. So that tells me it's a quadratic sequence, right? So we need to find this fellow over here. So second difference. We get that everything's a 6, 6, 6. And we are going to now half that. Remember I told you we take that 6 and have it. That's 3. So that is the number that goes over here. Okay, so now we have to see what a 3x squared sequence goes by. So we're going to do that. I mean, numbers here 5, so let's do the first 5 terms in a 3x sequence. So basically you're replacing a 1 in here, and then a 2, and then a 3, a 4, a 5, and 6, or however long you want to make that. So if I substitute a 1 here, oops, right, so we put a 1 in here, number 1, it'd be 1 squared times 3, which is 3. We substitute 2, it would be 2 squared, which is 4 times 3, we get 12. 3 squared, right? Third term would be 3 squared, which is 9 times 3, we get 27. And then 4 squared, which is 16 times 3, which is 48. Okay, and then let's do one more. And then 5 squared would be 25 times 3, 75. So now what we want to do is we want to remove this sequence, right, from the original one. Right, so we're going to take this and subtract it from that. So let me highlight the 2 lines I want you to subtract. This, that's not a highlight. Is it? Okay, that's very, maybe I should just, sorry. No. So we're going to subtract this line, and I'm going to this one and this one. So 6 minus 3 is 3. 17 minus 12 is 5. 34 minus 27 looks like a 7. 57 minus 48 looks like a 9. And 11, right? So we have, so again, now our answer, slowly we're getting a little function here, right? So we got that part, but there is more. So after removing that, we start all over again because we have another sequence inside a sequence. So let's find the first difference. 2, 2, 2, 2. So we have a linear sequence, right? Because everything is the same in the first difference, so it's a 2x sequence. How did 2x go? Well, 2x sequence is 2, 4, 6, 8, 10, right? So 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. 8 and 10. Right, so I know, let me add this, plus 2x. And then, and again, the 2x, the sequence is 2, 4, 6, 8, but notice that I don't really want 2, I don't really want 4, I want 6 or 8, 10, I want 3, 5, 7, 9, 11. So what adjustments do I have to make to the 2x sequence so that I get 3, 5, 7, 9, 11? So to that, I can add 1. So 3 minus 2 is 1, 5 minus 4 is 1, 1, 1, and 1. So if I subtract these two, you get that number, right? Okay. And again, you can substitute, and we have 5 numbers here. I mean, plug in the number 5. Plug in the number 5 in there, right? In there and in here, and see if you get 86. Plug in the number 3 again in place of x, and see if you get 34. You should always double check. Okay. And we already did it in class, so I'm not gonna double check it, but I'm just going through the procedure here. Okay. So again, nothing too crazy. First difference looks like a 9, 13, right? 29, 16, 13, 46, and 19 is 17, and 67, 46 looks like a 19. So it's not a linear sequence. So we take the second difference. You can tell it's 2, it's 2, 2, which means, right, so we take that, divided by 2, gives us 1, and our coefficient is 1, which we are not really going to write it down because it's not necessary. So how does an x squared sequence go? Well, x squared, substitute, let's do the first 5 numbers. 1 squared is 1, 2 squared is 4, 9, 16, 25. So we're going to remove this sequence from the original, which is this one, the original. And we're going to subtract. So 7 minus 1 is 6. 16 minus 4 looks like 12. 29, 6 is, 29, 9 is, sorry, 20. 46 and 16 is 30. Am I doing something wrong here? (46) and 16 is 30. 29 and 9 is 20. 16 minus 4. Sorry guys. 7 minus 1 is 6. 16 minus 4 is 12. And 67 is minus 30. 25 is something. 42. Okay. So from here, we're going to take the first difference again. Okay. Let me just double check. 7 was 6. 1 squared. Sorry, guys. All right. Oh, I see where my mistake is. Oh, sorry. So my problem here is that I wrote 2. It's 4, 4, 4. That's why things were not working. So, right. So we take that, have it, and get 2. So this would have been 2. Whew. All right. So now let's go in. So 2x squared. Let's see what a 2x squared sequence go. So 1 squared is 1 times 2 is 2. 2 squared is 4 times 2 is 8. 3 squared is 9 times 2 is 18. 4 squared is 16 times 2 is 32. 5 squared is 25 times 2 is 50. Now this we subtract again from the original. 7 minus 2 is 5. 16 minus 8 is 8. 29 minus 18 is 11. 46 and 32 is 14. And 67 is 17. Okay, good. So now this becomes our new sequence, right? And we're going to start everything again. So our answer so far, we know part of it is 2x squared. There's probably a little bit more. Find the first difference of our new sequence. So we get 3. So find the first difference. We get 3, 3, 3. So there is a linear sequence in here, and that number is 3. So what does a 3x sequence looks like? It looks like 3, 6, 9, 12, 15, right? So how do I adjust a 3x sequence so that instead of 3 I get a 5, instead of 6 I get an 8, instead of 12 I get a 14? So I would adjust it by adding plus 2. So its second part would be 3x, and to make a little adjustment because I want to get 5, 8, 11, 14, and 17, I add plus 2. And you could have also subtracted. 5 minus 3 is 2, 8 minus 6 is 2, 2, 2, 2. And that gets right there. Okay. We'll do one more. I think I remember that was that last one that didn't work. One second. So first, you get 5, 7, 9. Oh, look at that, 11. So second difference. Now you get 2, 2, and 2. So we know it's a quadratic sequence. And then 2, we divide by 2, we get 1. And that's the number that would go in here. But we're not really writing it because it's redundant to write it. So it's an x squared sequence. An x squared sequence, the first term is 1. The second term is 4 because 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. So that'll be the next. So we got this part, right? There might be others. We subtract this from the original, right? We're going to subtract this sequence from the original. So we get, right, so this one and this one, and we subtract. 3 minus 1 is 2. 8 minus 4 is 4. 9 minus 15 minus 9 is 6. 24 minus 16 is 8. And 35 minus 25 is 10. So we work with our new sequence here. Take the first difference. We get 2, 2, 2, 2. So we know there is a 2x sequence, right? A linear sequence. How does a 2x sequence go? It goes 2, 4, 6, 8, 10. So we actually get exactly what we want. We actually get a 2. We actually get a 4 because we want a 4. So it's x squared plus 2x. And guess what? This one, if you subtract, you have 0, 0, 0. You can, if you do plus 0, there's no point, right? So, and that's our answer. Oops. Just made it really ugly. 2x. Okay, so that, again, see if you get 3, substitute the 1 there, right, to see if your first term is 3, substitute a 5 instead of the x's, right, and see if you get 35. Okay, so that would be something that I definitely recommend you would do on your test. Okay, so this we failed, and let's see why we failed. Let's see if I can figure out what we did wrong. So that's 4. 37 and minus 9 is 28. $65 and 37. It's 28 again. That was on this. Okay. All right, so I'm not going to do the last one. Okay, so, and we're done.